Dear students, in the last module, we discussed about the structure of Python and its elements. In this module, we are going to see about Python interpreter and how to use Python as a calculator. We always write a computer program using a high-level language. A high-level language is one which is easily understandable by us. But a computer does not understand high-level language. It can only understand the program written in zeros and ones in binary called the machine code. Do you think writing programs using machine language is easy? No, it is very difficult for us to write programs in machine code. We have many high-level languages. A program written in high-level language is called a source code. We need to convert the source code into machine code, and this is accomplished by compilers and interpreters. So, compilation and interpretation are two different methods for executing a program written in a high-level programming or scripting language, which are carried out by compilers and interpreters respectively. Hence, a compiler or an interpreter is a program that converts program written in high-level language into machine code that can be understood by the computer. A compiler takes entire program and converts it into object code, which is stored as an .obj file. The object code is also referred as binary code and can be directly executed by the machine after linking by linkers. The compiled programming languages include C and C++. An interpreter directly executes instructions written in a programming or scripting language without converting them to an object code. But this process produces bytecode which can be run by a virtual machine. Examples of interpreted languages are Perl, Python and MATLAB. Let us see the workflow of compilation and interpretation process. Now, let us differentiate between source code, object code, bytecode and machine code. What is source code? Source code is the code written as per the specification of a programming language and could be compiled or interpreted and can be executed as machine code that runs on CPU. Source code is in human readable form which may or may not be cross-plot form. Let us move on to object code. Object code is created when a source code is compiled. This is an intermediate code which will use linker to convert it into an executable format called as machine code. Object code is similar to bytecode, but it is generated from different source code on a given platform. This enables mixed language programming but may not be portable across platforms. Next comes bytecode. Bytecode is intermediate code between source code and machine code that is executed by a virtual machine. This is a machine independent code which makes bytecode portable across multiple platforms as long as a virtual machine is implemented on that platform. But machine code is directly executable by the computer and tailored for a specific processor. Now, coming to Python, it is bit strange in terms of compilation. Remember this word, Python is a compiled interpreted language. When Python program is run, first Python checks for errors in the program. Next, compiles and converts it to bytecode, and directly bytecode is loaded in system memory. Finally, compiled bytecode is interpreted from memory by virtual machine to execute it. Whereas, the languages like C or C++ converts programs to object code and then to machine code and saves them as executables in disk and then user can run. When we execute a Python source code, Python compiles it into a bytecode. Compilation is a translation step and the bytecode is a low-level platform independent representation of source code. Note that the Python bytecode is not binary machine code. Actually, Python translates each statement of the source code into bytecode instructions by decomposing them into individual steps. The bytecode translation is performed to speed up the execution. Bytecode can be run much more quickly than the original source code statements. Students, till now we discussed about Python compilation process. Let us see the interpretation process of Python in detail. Python compiles the source files, that is .py files, and saves it as .pyc files. So, it can reference them in subsequent invocations. The .pyc contains the compiled bytecode of Python source files, which is what the Python interpreter compiles the source to. This code is then executed by Python's virtual machine. There is no harm in deleting them, but they will save compilation time if you are doing lots of processing. Python is an interpreted language when compared to the compiled one. Compiling usually means converting to machine code, which is what runs the fastest. But interpreters take high-level language statement and execute it. They may do this with an intermediate stage. For example, when you run test.py source file, the Python interpreter first looks to see if any test.pyc, which is the bytecode compiled version of test.py exists, and if it is more recent based on the time than test.py. If so, the interpreter runs it. If it does not exist, that is test.py is more recent than it, meaning you changed the source file, the interpreter first compiles test.py and produces test.pyc. A star.pyc file is created for imported modules and they are placed in the same directory containing the .py file. However, no .pyc file is created for the main script for your program. In other words, if you call Python myscript.py on the command line or run from IDLE, there will be no .pyc file for test.py. This is the case with Python 2.x, but in Python 3.x, the .pyc files are saved in a pycatch directory. Please do remember that running a script is not considered an import and no .pyz will be created. For example, if you have a script file test.py that imports another module mod1.py, when you run test.py, test.cpython.37.pyz will be created, but no mod1.pyz file will be created since mod1 is imported module. Let us summarize what happens behind the scenes. When a Python executes a program, Python reads the .py into memory and parses it in order to get a bytecode, then goes on to execute. For each module that is imported by the program, Python first checks to see whether there is a pre-compiled bytecode version, that is .pyz, that has a timestamp which corresponds to its .py file. Python uses the bytecode version if any. Otherwise, it parses the module's .py file, saves it into a .pyz file and uses the bytecode it just created. Bytecode files are also one way of shipping Python codes. Python will still run a program if all it can find are .pyz files, even if the original .py source files are not there. Once our program has been compiled into bytecode, it is shipped off for execution to Python virtual machine called PVM. The PVM is not a separate program. It need not be installed by itself. Actually, PVM is just a big loop that iterates through bytecodes one by one to carry out their operations. The PVM is the runtime engine of Python. It is always present as part of the Python system. It is the component that truly runs Python scripts. On Windows machines, the Python installation is usually placed in C:/Python 37, though it may vary from computer to computer. It depends on the path chosen during installation. If you are having any clarification, then refer the previous modules. If you have not chosen add Python 3.7 to path during installation, then you can add this directory to your path by typing the command set path is equivalent to %path %c:/python 37 in the command prompt in a DOS. Typing an end of file character, that is Ctrl+Z, at the prompt causes the interpreter to exit with a 0 exit status. If that does not work, you can exit the interpreter by typing the command quit. The Python interpreter installation is already demonstrated in previous module. To open the Python interpreter, type Python in the command prompt as shown. When you start the Python, it prompts for the next command, usually 3 greater than signs. Otherwise, you can also open the interpreter as discussed in our previous module. Python interpreter offers some features such as interactive editing, history substitution and code completion on systems with support for readline. There are 4 steps that Python interpreter performs when you press return. They are lexing, parsing, compiling and interpreting. Lexing is breaking the line of code just typed into tokens. The parser takes those tokens and generates a structure that shows their relationship to each other. This structure is known as abstract syntax tree called AST. The compiler then takes the AST and turns it into one or more code objects. Finally, the interpreter takes each code object, executes the code it represents. Let us now get into how to use Python interpreter as a calculator. One of the most important tasks that a computer performs is mathematical operations. As other programming languages do, Python provides a direct interface to do the mathematical computation. Eventually, an introduction of Python could start by demonstrating how it can be used as a tool for simple mathematical calculations. The easiest way to perform mathematics calculation using Python is to use Shell, the interactive development environment of Python, which can be used as a calculator. To start with, let us perform simplest mathematical functions including addition, subtraction, multiplication and division. Let us see the commonly used arithmetic operators. How to use these operators at the shell prompt to perform calculations. As can be seen from the examples, a simple Python expression is similar to a mathematical expression. An expression involves operands and operators. In programming terminology, numbers, for example, 3, 5, 4 are called literals. Since expressions themselves represent values, they can be used as operands in lengthier expressions. In this example, the sub-expression 21 plus 4 is evaluated first. Its value 25 is added with next literal 2, leading to the intermediate result 27. This value is in turn used for subtracting 6, which ends up with the answer 21. The expression is evaluated from left to right because plus and minus have the same priority, but in general the operators have different priorities. For instance, consider the expression 5 plus 1 star 3. This expression evaluates to 8 because the multiplication operator has a higher priority compared with the plus operator. The order in which operators are applied is called operator precedence, and mathematical operators in Python follow the natural precedence by the mathematical function. For example, multiplication and division have higher priorities than addition and subtraction. The precedence and the associativity of the operators will be discussed in detail in forthcoming module. So, for all the expressions in the discussed examples are integer expressions of which all the operands and the value are integers. But for the expression 4 divided by 3, the real number 1.33 is a more accurate value than 1. In Python, real numbers are typically called floating point numbers. To perform floating point arithmetic, at least one floating point number must be present in the expression, which results in a floating point expression. Regardless of operands, when all the numbers in a Python expression are integers, the expression is an integer expression and the value of the expression itself is an integer. However, when there is at least one floating point number in an expression, the expression is a floating point expression and its value is a floating point number. When plus, minus and star operators can all be applied to floating point numbers, resulting in floating point numbers. The type of a literal or expression can be examined by various commands. The command type of x returns the type of x. We call a function with specific arguments in order to obtain a specific return value. Function calls are also expressions which are returned in a form similar to mathematical expression with a function name followed by a comma separated list of arguments enclosed in a pair of brackets. The value of a function call expression is the return value of the function. Intuitively, the return value of a function call is decided by both the function and the arguments of the call. To illustrate this, consider two more functions. The int function takes one argument and converts it into an integer, while the float function takes one argument and converts it into a floating point number. From these examples, we know that both the functions and the arguments determine the return value. Function calls have higher priorities than mathematical operators in operator precedence. The int function converts a floating point number into an integer by discarding all the digits after the floating point. A value can be assigned to several variables simultaneously at the prompt. Now, let us try simple Python programs at the shell prompt. First program is to find the area of a square. There are 3 lines of code in the program. The first is an assignment statement, assigning a value 1 to the identifier side. The second is another assignment statement which evaluates the value of side multiplied by side to the identifier area. When this line is executed, the right hand side of equal is first evaluated according to the current value of side. The result is 16. This value is in turn assigned to the identifier area, resulting in the new value 16. The third line is a single expression wherein the value is displayed. Jenny spent X dollars, then she spent Y more dollars, and then she spent Z dollars and C cents. Find the total amount spent by Jenny. Find the remaining amount after distributing X amount to. Let us see the next problem. Anand spent X rupees, then he spent Y more rupees, and then he spent Z rupees and C paise. Find the total amount spent by Anand. Find the remaining amount after distributing X amount to M person. Assume that the total amount is N. Now, we are going to discuss about scientific notation. Integers are the small numbers without decimal point. For example, 24, 29, 1997 are integers, but 1.23, 24.11, 2.0 are not integers. Floating point or real numbers are the numbers which have decimal point. For example, 1.2, 0.21, 39.0 are float, but 102, 8 are not. We can also write float point number using scientific notation. The numbers written in the form m multiplied by 10 cap 1 is known as scientific notation. For example, 1.2, 0.21, minus 99.0 are float, but 102, minus 8 are not. We can also write floating point number using scientific notation. The numbers written in the form m multiplied by 10 power b is known as scientific notation. scientific notation is quite useful for manipulating very small or very large numbers. For example, float 0.0000000067 can be written in scientific notation as 6.7 multiplied by 10 power minus 8. Python uses a special syntax to write numbers in scientific notation. For example, 0.00000067 can be written as 6.7e minus 8. The letter e is called exponent and it can be written either as small e or capital E. Let us summarize the contents of this module. In this module, we discuss about how to use Python as a calculator. I hope you understood. Thank you. Have a nice day.